In this video, I will show you what it takes to prove that two triangles are congruent. And once we have congruent triangles, we're going to make a congruence statement and find unknowns. Let's start off by finding out what it takes to prove that these two triangles are congruent by SAS. Now, SAS stands for side, angle, side. But there's one word I need to add to the mix. Notice that the A is between, that's the missing word, between the two S's. The A is between the two S's. That means that the angle is between the two sides. All right, so I need an angle that is between two sides. So here I have one side that's already marked for me. And I see I have the angle right here. So I need to put the other side so that it puts the angle between the two sides. So if I put my other side here, then the angle is between the two sides. The angle is where the sides meet. Now, I need to do the same thing on the other triangle. So here's the side I already have. That's already marked. Here's the angle that I have. This angle needs to be between the two sides, so the other side must be here. I'll put a double mark on that. So this information would prove the triangles are congruent by side, angle, side. I have two sides and the angle in the middle, congruent to two sides and the angle in the middle, the angle between them. Let's go ahead and make the congruence statement. Triangle ABC is congruent to triangle what? Well, angle A is connected to the double side, and angle F is connected to the double side. So those are going to be corresponding. What else? Angle B is over here connected to the single side, like angle E is connected to the single side. And that leaves angle C, which of course matches angle D. Those are both right angles. All right, let's move on to part B. Okay, HL stands for hypotenuse leg. So that means the hypotenuse of the triangle has to be marked. And it's not already marked, so we have to add that in. So there's the hypotenuse across from the 90-degree angle. And same on the other triangle, here is the hypotenuse across from the 90-degree angle. Leg, hypotenuse leg. A leg is just any other side other than the hypotenuse. So we see that we have the leg already marked. So this is hypotenuse leg. So that would do it. That would prove that these triangles are congruent. Let's go ahead and make the congruent statement. Well, you know what? This is exactly the same. Is it the same? Okay, so triangle ABC is congruent to triangle. Yeah, so angle A is touching the double. Okay, it's between the blank side and the double, and that'll be F. Okay, so it's going to be the same thing, FED. That's what I thought. All right, moving on. Okay, this stands for angle, side, angle. Again, let's get the word between into the mix. Can you see that the S is between the two A's? That means the side has to be between the two angles. Okay, so for angle side angle, I need two angles and a side. So I already have my one side. I have one angle. I need two angles. So I need to pick another angle, but I need to pick it so that the side is between the two angles. That is really important. Okay, so I already have one angle right here. Let's say if I were to foolishly pick this as my other angle, then these would be my two angles, and then this would be my side between. But this is the wrong side because I need it to be this one. All right, that's why in addition to the angle I already have, the other angle I'm going to pick will be angle B. All right, that way, if I were to connect these up, this is the side between them. And that's the side that we have marked. So in this way, the side is between the two angles, so this will work out great. And I need to do the same thing over here. I need to pick another angle, but I need the angle to be the angle that makes the side between the two angles. So if I pick angle E, then the side marked is between the angles. So I'm going to definitely pick E. So these markings would show that the triangles are congruent by angle, side, angle. Let's go ahead and do the congruence statement. Triangle A, B, C is congruent to triangle what? Angle A is across from the single side. Angle F is across from the single side. Okay? Angle B has the swoop. Angle E has the swoop. And angle C has the 90 degrees. Angle D has the 90 degrees. Okay, now part B. This stands for angle, angle, side. That's two angles and a side. Now look, on the last problem, we had two angles and a side. But the side was between the two angles. This time, the side is over here off to the side. It is not between. And that is how I want you to think of it. So I need two angles and a side. Right now, I have the side, but I only have one angle. So I need to pick another angle. So let me mark this one first. I need another angle, but I'm going to pick it so that the side is not between the two angles. So if I pick angle A, for example, let's say if I pick angle A, this is the side between the two angles now. And the marked side is not between. So this is good. All right, now again, on the other triangle, I need to pick another angle. So if I pick angle F, I already have angle D. This is the side between. So the marked side is not between. So this is what we want. So I'm going to pick angle F so that the side is not between the two angles. All right, so that is the marking that we're going to need. So these two triangles are congruent by angle, angle, side. Two angles and a side not between them. Time for the congruent statement, but let me guess. Triangle ABC is congruent to triangle FED. All right, but let's just check real quick. A is a single swoop, F is a single swoop. Okay, angle C is the right angle, angle D is the right angle. And that leaves angle B and E. Okay, let's solve some stuff. All right. Triangle PQR is congruent to triangle STU. I think it would be helpful to draw some triangles just to help us kind of visualize what's going on. All right, so here's a triangle, and here is another triangle. All right, I'm going to spread them out a tiny bit. All right, what is up? PQR. So this is triangle PQR. All right, I'm going to label them the same way. So triangle STU. So I'm going to do the same thing. STU. All right, so I've drawn the triangles rotated the same way so that the corresponding sides and angles all line up perfectly. That will just help us solve the problem more easily. Circle the pair of lengths that must be the same. Okay, so PQ, I know that PQ must be the same as ST. All right, so PQ, do I see an ST? No. All right, okay, QR. I know that QR must be the same as TU. Okay, so QR must be the same as TU. All right, SU is the same as PR, but I only see SU, I don't see PR. So these are the two that must be the same. Okay, now, do I have expressions for those? Okay, so I have QR is right here, and I have TU, which is right here. Those have to be the same. So we can go ahead and set those equal to each other, and that will give us 8x minus 4 equals 7x plus 1. If you subtract 7x from both sides, that's going to give you x minus 4 is equal to 1. Now add 4 to both sides, and you get x is equal to 5. All right, now we need to find PQ, QR, etc. Let's start with PQ. Actually, let's not start with, yeah, okay, we can start with PQ. PQ, we have an expression for that right here. Okay, so using this expression, 5x plus 7, this is going to become 5 times 5 plus 7, all right? Because we already found out that x is equal to 5. So I'm plugging it in. That's going to be 25 plus 7, which is going to be 32. So PQ is 32. Okay, so that means this is 32, and this is 32, by the way. Okay, by the way, so ST, that's over here. So might as well fill that in right now. So ST is 32. All right, what is next? Well, now I can find QR. All right, so here's a nice little expression for QR. So I'm going to do that right over here. So that's going to become 8 times 5, all right, 8x minus 4. So 8 times 5 minus 4. So that's going to be 40 minus 4, which is going to be 36. So QR is 36. So that's right here. And these are corresponding sides, so that means TU is also 36. All right, no need for me to plug anything in there. I already know that they're equal. Okay, now let's move on to US. We have a tiny little expression for US right here. Okay, so I'm just going to do that off to the side. So 6x, that will become 6 times 5. Whoops. And obviously that is 30. So US is 30. And that corresponds with PR, which will also be 30. All right, we got them all. Okay. Given triangle JOG is congruent to triangle RUN, fill in the blanks. Okay. OJ. OJ is right here. All right, it's the first two. So segment OJ is going to be congruent to segment RU or UR. All right, you really could say that either way. All right, but I know that those two go together. Okay, segment GO. GO is right here. That corresponds with NU. Okay. Well, angle G is going to correspond with angle N. They're both at the end. All right, angle G is congruent to angle N. Okay, angle R is going to be congruent with angle J. They're both at the beginning. Okay, and finally, triangle GJO. So we just have to put the letters in the correct order. Okay, triangle G. So G goes with N. J. Let's see. Well, okay. J goes with R. And O. O goes with U. All right. Triangle UNR. Okay, U goes with O. Now it's time for N. N goes with G. All right, they're both at the end. And that just leaves R and J. Okay. Triangle PQR is congruent to triangle STU. All right, this seems similar to what we did up here. So I think I'm going to do the same strategy, and I think it was helpful to draw the triangles. So I'm going to do that again. All right, so here's a triangle, and here's another triangle. All right, so we have PQR is congruent to STU. Okay. Now, we have an expression for PR. So here is our PR. Okay, and PR is like this side right here, by the way. So that's going to match SU. Oh, and there's SU right there. So those should be congruent, PR and SU, PR and SU. So let's set these equal to each other right now. Okay, so if I set these equal to each other, I'm going to have 6x minus 5 equals 2x plus 7. Subtracting 2x from both sides will give me 4x minus 5 equals 7. Add 5 to both sides, and I get 4x equals 12. And then when I divide both sides by 4, I get x is equal to 3. So find x is equal to 3. And then finally, I need to find TU. All right, TU is right here. A simple little expression. It's 5x. So I know that's going to be 5 times 3, because x is 3, and that is 15. So TU is 15. Okay, I guess that's all we had to do. That problem was a lot simpler. All right. You might find it helpful to draw a picture first. Okay, so we have triangle ABC congruent to triangle DEF. So maybe this is the more complex version of what we just did. So let's use the same strategy one more time. Okay, here's a triangle. Here's another triangle. I'm just going to move these over a bit. Okay, so one triangle is ABC. So here's triangle A, B, C. And that's congruent to triangle DEF. So I'm going to go in the same order, D, E, F. All right. So they gave us some stuff. AB is 60. All right, so AB is 60. So I'm going to go ahead and put a 60 right there. Now, you know what? As I go, let's just fill in everything. So if AB is 60, that means DE is also 60. All right, because these are congruent. Might as well knock it out. EF is 72. So here's EF over here. This is 72. That means that BC has to also be 72 because these are corresponding sides. AC is 66. All right, so this is 66. That means that DF must also be 66. All right, so that's useful to know. So I need to find the value of x. I have an expression for BC. All right, I see an x in there. So BC is 4x plus 12. All right, now BC is this side right here. All right, so this is BC, is 72. So that means if BC equals 72, that means that 4x plus 12 must equal 72. So we should be able to just solve this for x very quickly. So subtracting 12 from both sides, this will give me 4x is equal to 60. And so x is equal to 15. All right, maybe I should have showed that last step. I am dividing both sides by 4. And that gives me x equals 15. All right, now I need to find the value of y. I see a y right here. That's df. Where is df? Here's df right here. Okay, so that should equal 66. So that means that 6y minus 12 should equal 66. Let's add 12 to both sides. That's going to give me 6y is equal to 78. And then we divide both sides by 6, and that tells us what y is. $13. All right, time to find the value of z. Okay, so z is down here. We're dealing with angle measures now. So let's fill in some things. So angle F is 71. So here's angle F. So this angle is 71 degrees. That corresponds with angle C though. So that means that angle C is 71 degrees. Interesting. People, do you see what I see? Look, we have angle C and we have angle F. Okay, I'm going to use angle C right here because I have an expression for angle C right here. So, if angle C is 71, that means this expression should equal 71. So that means 8z minus 9 should equal 71. So let's add 9 to both sides. And that is very convenient because we get 8z is equal to 80. And then if we divide both sides by 8, we get z is equal to 10.